So this is the first video in our new unit, Unit 2.4 for SOHCAHTOA, or a unit on trigonometry. So here's an introduction to some trigonometry. We have three things and they look kind of funny. The first one is sine. The second one is cosine, and the third one is tangent. Now be careful that you don't pronounce this as sin, as it is sine, cosine, and tangent. So when we have our three trig functions, we write them in shorthand as sine, don't call it sin, cosine, and tangent. And these three are going to be the ones that we're going to use the most often. So let's go ahead and break it down. If I look at these two triangles and I tell you that triangle ABC is similar to triangle DEF, you automatically know a few things. You know that angle C would be congruent to angle F. And we know that because similar triangles have congruent angles, and then we know that the sides are in proportion with one another. So that's going to be really useful when we start talking about sine, cosine, and tangent. Okay, so looking back at what we already know, we know that these two triangles are similar, and we know that C is congruent to angle F. So because of that, we know something. We know about our relationships. We know that BA, this side over here, has to be in a relationship over here with ED, right? Because they're both across from the same angle, so they have to be in a relationship with one another. And we know that our hypotenuses also have to be in a relationship with one another because these triangles are similar. This is something that we know. So in words, what I just did here is if I look here, this is across from my angle. Do we all see that? So BA is across from angle C and ED is across from angle F. And BC is my hypotenuse and EF is my hypotenuse. So in words, what I've just written is the length of the side opposite the angle over the length of the hypotenuse. So what I've just done here is I've actually told you how to find the sine of an angle. And sine, cosine, and tangent, they're just ratios. That's all they are. So if I tell you the sine of an angle, we're going to use the Greek letter theta. It looks like a 0 with a line in the middle. So sine of theta would equal the opposite over the hypotenuse. So if I look back into my mnemonic that I know that you probably thought was kind of weird, that's just so. Sine is the opposite divided by the hypotenuse. So now let's see if we can do it with cosine. So if I think back to my similar triangles, I know that angle C is congruent to angle F, which means that CA has a relationship with FD. And BC again is in a relationship with EF. So what that is in words, here's my angle that I'm talking about. This one right here is next door. So another word for right next door is adjacent. So I have this in words, it's the length of the adjacent side. Now adjacent means the leg that forms our right angle, and it's right next door. So in this case, think about our 45, 45, 90 or our 30, 60, 90 triangles. When we had to go all the way across, that's the opposite. And right next door, this one's the adjacent, and the one across from the 90-degree angle is always going to be our hypotenuse. So this is all divided by the length of the hypotenuse. So what we found out is that the cosine of the angle, again that's theta, like a 0 with a line in it, would be adjacent over hypotenuse. So sine was opposite over hypotenuse, and that's where we got so. So this is where we get ka. SOHCAH. Cosine is the adjacent over the hypotenuse. So we've talked about sine and cosine. Now we have one more left that we need to talk about, and that's tangent. So again, thinking back to our similar triangles, I know that BA is in a relationship with ED and AC is in a relationship with DF. So again, if I think about being right here at this angle, I go across to the opposite side, and then I end up being right next door. So in words, what we found out is we have the length of the opposite side divided by the length of the adjacent side. All right, so if I think about this in terms of tangent of my angle, again, that's theta, 0 with a line in it. Tangent of theta would be my opposite divided by adjacent. Okay, and so we've talked about sine, cosine, SOHCAH. This is where we get TOA. All right, so let's write that whole mnemonic out. So I have SOHCAHTOA. So what this means is sine is opposite divided by hypotenuse. Cosine is adjacent divided by hypotenuse. And then we have tangent, which is opposite divided by adjacent. All right, so SOHCAHTOA is going to be your best friend when it comes to solving problems. So let's jump in and see if we can figure out some of these. Okay, so I have this triangle here that has 2 of the 3 sides. I know one's a right angle, and I have these 2 funny letters. So when you have a letter that looks like this little fish thing, that's called alpha. It's the Greek letter for A. When I have this weird B thing with a tail at the bottom, that's the Greek letter beta, which is the Greek letter for B. So I want to find the sine of alpha, the cosine of alpha, and the tangent of alpha, and I'm sitting right here at alpha. So this is where we want to look. This is where we want to be. So I'm going to go ahead and mark that this is the area where we're looking at. So everything from here. Well, sine, okay, so sine, let's write our mnemonic down. So we have SOHCAHTOA. And sine is opposite over hypotenuse. Well, I don't have my opposite. So the first thing I need to do is figure out what's that missing length. So let's do that. Find the missing length. And how do we do that? Well, I have a right triangle. I have 2 of the 3 sides. The answer should be pretty obvious that we're going to use the Pythagorean theorem. So I'll call the missing side x. So x squared plus 3.2 squared equals 4 squared. You can do the math, blah, blah, blah. You get that x is equal to 2.4. So I'm going to write that in right there. All right, so now it's pretty straightforward for me to be able to find my sine, cosine, and tangent. So sine of alpha is going to be the opposite, so 2.4, right? I have to go opposite over hypotenuse. So we're divided by 4. And I know what 24 divided by 4 is, so I just have to add a decimal in there. So 0.6. Let's see, the cosine of alpha, well, let's think back. That's adjacent over hypotenuse. So that's my adjacent divided by hypotenuse. So that's 3.2 over 4, and I know what that is, 0.8. And then I have my tangent. And so tangent's a little bit different, right? These are pretty straightforward, but tangent is opposite over adjacent. Opposite over adjacent. So when I do my tangent of alpha, I have opposite, which is 2.4, divided by the adjacent of 3.2. Now I can reduce this. I know 4 goes into both of those, so I'm left with 0.8. Oh, no, I'm not left with 0.8. 24 divided by 4 is 0.6 over, we know 3.2 is divisible by 4, and we get 0.8. What do you notice just happened? Well, I have sine of 0.6, well, that's right here. And cosine of 0.8, well, that's right here. So that's going to be an important thing to remember. A side note is that the tangent of anything is equal to the sine of that thing divided by the cosine of that thing. And that's just a good thing to keep in mind. So we can keep going and say, okay, well, I can do this. I can divide them both by 2. I get 0.3 divided by 0.4, which is the same thing as 3/4. So the tangent would be 3/4 or 0.75 if you want to keep it in decimal. Okay? So again, keeping in mind this important thing right here, this identity, that tangent is equal to sine divided by cosine. All right, why don't you take a minute and find the sine, cosine, and tangent of beta. So again, you're missing a side. Think about what we had to do, and then think about, are you over here at alpha or are you here at beta? So take some time and do this, and this is where we'll start off with class.